Okay, so now we are in session 2, page 102. We're just doing some practice. There's nothing new. We are just applying what we know about dilations and the 3 rigid transformations. So number 4, we're going to annotate, and you want to make sure that when you're annotating, you're doing these steps. So we have Grace. She wants to rotate 90 degrees clockwise around the origin. So clockwise is this way. She's here in quadrant 2, so 90 degrees clockwise will put her in quadrant 1. Then she wants to dilate, scale factor of 2, origin as the center. So scale factor of 2 means the shape is going to get bigger. And the math we're doing is we are multiplying by 2. So first, the rotation, second, the dilation. Her work is shown. They want to know what mistake did she make. That's the third thing we're doing. And then finally, what are the actual correct coordinates of the vertices for the double primes? So let's see what she did wrong. So we have the pre-image here. Oh, just kidding. Pre-image is in blue. 90-degree rotation is here, and that's correct. She rotated 90 degrees clockwise, and then her dilation is here, and she did dilate it times 2, but she messed up. So what did she do wrong? Well, her mistake was, instead of dilating the image here in quadrant 1, she went back and dilated the pre-image. So we're going to write that right here. Grace dilated the pre-image, not the image. That's her mistake. So now they want to know, where should the dilation have been? So what we need to do is we need to multiply this shape here. We need to multiply the coordinates times 2. So that means we need to write out these coordinates for the primes. So P prime, P, Q, R, S prime. We need to figure out where those are. P prime is at 3, 5, it looks like. Q prime is at 3, 2. R prime 1, 2. And S prime 1, 5. So we're going to multiply these by 2, and that is going to give us where our double primes should be. So times 2 gives me 6, 10, 6, 4, 2, 4, and 2, 10. Next question, we have 2 transformations are done on triangle X. First, it's rotated counterclockwise around the origin. Then it's dilated using a scale factor of 3/4, which makes it smaller. I am multiplying by 0.75. Now, after a rotation, so after the first transformation, the shapes are still congruent, because remember, rigid transformations only change the orientation and location. So it's still the same size after the first transformation. Now the dilation made it smaller. So now the shapes are only similar. They're no longer congruent. So X is similar to X prime, X double prime, yes. X is congruent, no. It's congruent and similar, no. It's neither, no. So the shapes are similar. All right, last problem. And this one, there's a quiz question just like this. So you're going to put a star by this one. We have Dario. He's dilating using a scale factor of 0.5, center at the origin. So it's going to get smaller. and we are dividing by 2, or you could multiply by 0.5. Same thing. After that, he's translating 3 units up. That means we are adding 3 to y. What are the coordinates of the vertices? Show your work. Okay, so let's go ahead and write out J, K, and L. So J is at negative 6, 4. K is at 1, 8. And L is at, K is at 2, 8. And L is at 2, negative 4. So to get my primes, I just have to look at my work here. I'm going to divide by 2. So everything is going to get divided by 2. So negative 6 divided by 2 is negative 3. 4 divided by 2 is 2. 1, 4. 1, negative 2. I'm going to go ahead and graph that, and then I'll be back. So after the dilation, this is the new image. Now we're translating up 3 times. So you can do the picture first or the coordinates. I'm just going to go ahead and do the math first. So to get my double primes, I'm adding 3 to y, so the x's stay the same. Adding 3, 2 plus 3 is 5, 4 plus 3 is 7, and negative 2 plus 3 is 1. So the new final image is here. And that's it. That's all for session 2.